Here is another example. Solve the equation 2 sine squared minus 3 sine of theta equals -1 for theta between 0 and 2 pi. Okay, the first thing you have to notice here is that this is a quadratic equation in sine. You can see that there's a square there, so this is a quadratic equation in sine. So if you remember from college algebra, the way to solve quadratic equations, the first step is you want everything on one side, usually the left, so you have 0 on the other side. So the first thing that I'm going to do here is to move the -1 to the left, and the equation is then going to become 2 sine squared of theta minus 3 sine of theta plus 1 equals 0. Okay, so that would be the first step. Then, just like a quadratic equation, now you decide which method you want to use. Basically, we typically use either of the following two methods. First one is factorization. Second one is quadratic formula. So make a choice. I typically prefer to factor whenever I can, and if I can't, then I use a quadratic formula. This one does factor, so let's go ahead and factor it. How do you factor this thing? Well, if you just notice, this is a quadratic equation in sine, so that means this is the same way, this is equivalent to factoring this. 2u squared minus 3u plus 1 equals 0, where u is sine of theta. Okay, I put or replaced the sine with u in order to make it easier to work with, but it's not really necessary. Okay, now that I have it like this, it's easier for me to think about how to factor it. This is, just take your time and factor it. This factors as 2u minus 1, u minus 1. So what that means then is that this factors like that. So it would be 2 instead of u sine. So 2 sine of theta minus 1, sine of theta minus 1 equals 0. Okay, now after you have factored it, set each factor equal to 0. So this is going to be 2 sine of theta minus 1 equals 0, or sine of theta minus 1 equals 0. Then you solve each of these and you're done. So let's solve each of these. 2 sine of theta minus 1 equals 0. To solve this, move the 1 and divide by 2. So you're going to get sine of theta equals 1/2. Note that this is a special trigonometric value, so that means we're going to get a special value for the angle. And this one you're supposed to know by heart. And what is this? Well, from memory, I know that the angle whose sine equals 1/2 is pi over 6, or 30 degrees. We're going to give the answer in radians, so pi over 6. Okay, so that's 1. There's usually more than 1, so we're going to try to figure out what's the other one. So draw your unit circle, so we can think of what's the other angle that has sine equal to 1/2. Pi over 6 is right here. Okay, so what is the other angle whose sine is also 1/2? Well, sine is the second coordinate, or the y-coordinate of this point. Another point on the unit circle that has the same y-coordinate would be, the y-coordinate is the height, so it would be this one right here. So that would be the other angle. What is the angle What is that angle right there in the picture? Well, it would be almost the full 180 degrees, or pi. So it would be almost pi, but with this little piece missing. This is symmetrical, so this little piece is the same as that one. So that means I would do pi minus pi over 6. Pi minus pi over 6, okay? So almost pi, but take that piece away. So pi minus pi over 6, that is 5 pi over 6. So that's the other possibility. One possibility is pi over 6. The second possibility is 5 pi over 6. So these are the possibilities that come from solving this equation. Now let's solve the second equation right here. That one says sine of theta minus 1 equals 0. Move the 1. You get sine of theta equals 1. And now what is the angle whose sine equals 1? Sine is, remember, the y-coordinate or the second coordinate. The only point in the unit circle whose second coordinate or y-coordinate is 1 is this one right here. So theta would be then pi over 2. And then you should always think, is there any other ones? And no, there's no other angle whose y-coordinate, right, corresponding y-coordinate on the unit circle is 1. That's the only one. So that's it. So we have our answers: pi over 6, 5 pi over 6, and pi over 2. All right, let's do another example. This one right here, it says solve the equation 3 cosine of theta plus 3 equals 2 sine squared for theta between 0 and 2 pi. After that, there's a follow-up question that says, what are the general solutions of the equation? Okay, first thing we notice, just like in the previous one, is that this is a quadratic equation. There's a square, the sign is being squared. However, this one has a little twist, and it is that there's sines and cosines combined. The other equation was all sines. This one has both sines and cosines combined. Generally speaking, having combinations of different trig functions is not good because it is hard to deal with. What we're going to do as our first step is to change everything in terms of sine or change everything in terms of cosines. Whatever is easiest, that's what you're going to change it to. Okay, and to change the sine squared, you will always want to change the square term. We're going to use the Pythagorean identity. Okay, and moving this to the other side, we get that sine squared of theta equals 1 minus cosine squared of theta, and that if we replace it right here, we're going to get 3 cosine of theta plus 3 equals 2, and then I replace the sine squared with 1 minus cosine squared. This is going to become 1 minus cosine squared of theta. And now the equation is all in terms of the same trig equation, namely cosine, so that's good. Now we can work with this. Okay, so now we're just going to proceed like in the previous example. This is a quadratic equation in cosine. First step is move everything to one side, so you have 0 on the other. Before I move everything, I need to distribute here. So this is going to become 3 cosine of theta plus 3 equals 2 minus 2 cosine squared of theta. Now I'm ready to move everything. this is gonna go here to the front, and the 2 is gonna get combined with that 3. So this is then 2 cosine squared of theta plus 3 cosine of theta. When the 2 moves, it becomes negative, so 3 minus 2. 3 minus 2 is positive 1. So positive 1 equals 0. And now you can solve this like any old quadratic equation. You can either factor it or use a quadratic formula. This one factors, so that's the way I'm going to proceed. Later on, we'll do an example where we use a quadratic formula because it doesn't factor. But for now, if we can factor it, we will. So factoring this is like factoring 2u squared plus 3u plus 1. If we know how to factor this, then that's exactly how you factor that, where u is the cosine. This one factors as 2u plus 1. U plus 1 equals 0. So that means this one then factors as 2 cosine of theta plus 1 cosine of theta plus 1. Then set each factor equal to 0. So this becomes 2 cosine of theta plus 1 equals 0, or cosine of theta plus 1 equals 0. Then solve each of these, and we're pretty much done. Okay, let's solve this one. Move the 1, that becomes negative 1, and then divide by 2. You get cosine of theta equals negative a half. Now, this one is a special trigonometric value. So the theta is going to be one of the special trigonometric angles, one of the special angles. So what angle is it though? All right, because it's negative, it's not among those that you're supposed to have memorized and know by heart. If it was positive, then it would be one of the ones that you're expected to know. So if it said cosine of theta equals a half, that's an angle that you should be able to tell what it is just from memory. This one is a negative, so it isn't one of them. But, however, if we know the positive one, then we can figure out the negative one. I know the positive one, so if the question was, what is the angle whose cosine is positive a half, then I know that that would be pi over 3. Okay, that's not the answer, but from here we'll figure out the right answer. Okay, so we have pi over 3. We're talking about the cosine. The cosine is the x-coordinate, so I want an angle whose corresponding point of the plane has x-coordinate equal to negative a half. The x-coordinates are in quadrants 2 and 3, so basically that means I want that angle right there. This angle has x-coordinate or first coordinate equal to a negative number, namely negative half. What is that angle over there? That is 2 pi over 3. Okay, and you can figure that out just the same way we figured the previous one out. It's almost pi, right? It's almost 180 degrees. It's almost pi. But you have these p's left out, and that p's by symmetry is exactly the same as pi over 3, so it will be pi minus pi over 3. And pi minus pi over 3 is 2 pi over 3. So that is the first possibility. There's another angle, though, whose corresponding point on the unit circle has also x-coordinate equal to negative a half. In other words, there's another angle with the same x-coordinate, and that is this one right here. And what is that angle? That would be pi plus pi over 3. So the other angle is pi plus pi over 3, which is 4 pi over 3. 4 pi over 3. And that's it. Those are the only two angles for that. For that equation, there's only those two answers. Now let's solve this one. Cosine of theta plus 1 equals 0. Okay, move the 1 to the other side. You're going to get cosine of theta equals negative 1. And then what are the angles whose cosine equals negative 1? Draw the unit circle. The cosine is the x-coordinate. The x-coordinate equal to negative 1. Well, that would be this point right here. There's only one angle whose x-coordinate equals negative 1. So that would be just pi. Right? That's it. There's no other angle whose x-coordinate equals negative 1 that is on the unit circle. That's it. So that answers the first part of the question, which is what are all the angles between 0 and 2 pi that solve the equation? Well, these are all the angles between 0 and 2 pi that solve the equation. The follow-up question was, what is the general solution? Meaning, if I was looking for all the solutions, not just the ones between 0 and 2 pi, what would be the answer? In that case, it's the same as that. The only difference is that you add the periodicity part, which is 2 pi n. Right, this is all the answers would be theta equals 2 pi over 3 plus 2 pi n, 4 pi over 3 plus 2 pi n, and lastly pi plus 2 pi n. Okay, let's do now some examples where the answer is not a special angle. All right, so let's solve this one. It says 4 cosine of x equals 3. When the answer is not a special angle, you really do need a calculator for this because it's not something you're going to know from memory. Okay, first thing is let's solve for cosine. Divide by 4. You get cosine of x equals 3/4. Okay, and how do you solve that? You probably remember how to solve this, right? We've done that before. How do you solve that? You hit it with cosine inverse. So x would be equal to cosine inverse of 3/4. And now you put this in the calculator. Now the problem says give your answer in radians. So make sure your calculator says radians before you enter this. Cosine inverse of 3/4, that is 0.72273428. Okay, I know the instructions say round to 4 decimal places, but you shouldn't be rounding until you're ready to enter your answer in the homework online system. So I'm not gonna round yet because I'm not done. Why am I not done? Because there's another answer actually. Just like in here, right? We have to use the unit circle in the picture to figure out what's the other angle. Once you know one, you can find the other one. So same thing here. So let's draw the unit circle real quick and figure out the second angle that works. Okay, the first angle is this one. In what quadrant is this angle? In what quadrant is that? Well, it is bigger than 0. This is 0 right here. That's the angle 0. And this angle here is pi over 2. Pi over 2 as a decimal, what is that? Pi over 2 as a decimal is about 1.57. So that is about 1.57. Because this number right here is between 0 and 1.57, that means that this angle is actually between 0 and 1.57, so somewhere in the first quadrant. So draw it somewhere, it doesn't really matter. Draw it somewhere. That's my angle, okay? Okay, I'm not gonna copy the whole thing, maybe. So just leave it like that. All right, so that's the picture for the first angle. What is the other angle whose cosine is the same? Cosine is the first coordinate. So what is the other angle whose cosine is the same? Okay, another angle whose cosine is the same, first coordinate is the same, would be right here. That's another angle with the same first coordinate, the x-coordinate. So then, I need to figure out what is this angle right there. That angle is almost 360. It's almost 2 pi. It is short by this little piece. That little piece is the same as that, so I need to take it away. So that means that other angle is 2 pi, almost a full circle, minus this piece, which is the same as that. So 2 pi minus 0.7227, and then that's why I don't want to round just yet, because you see I told you it was not done. And if you round it prematurely, you're going to get this wrong. So don't round until you really find both angles. So let's put this in the calculator. 2 pi minus 0.722734248. This is 5.5604511059. Okay, so now we're done. Now is when you round. I'm done with the problem. I'm about to enter it in, whatever online homework system we're using, WebAssign, or in this case, Hawks. Now we can round, and I would enter now 0.7227. That will be the answer for that one, and this one rounds off to 5.5605. All right, that's that for the first one. All right, let's do another one. Or you can try it on your own before you watch this. Okay, so let's do it. Move the 2 and divide by 5. That gives you sine of x equals 2/5. And now all we have to do is, at least for the first solution, hit this with sine inverse and get to the first solution. So this is sine inverse of 2/5. So what is that? Let's see. Sine inverse of 2/5. This is, don't round yet, remember, 411516,846. Okay, so that is the first solution unrounded. And now we need to find the other one. For the other one, for the second one, draw your unit circle. And find the other angle whose sine is the same. First thing is you need to figure out what quadrant this is. This one is again in the first quadrant. How do I know that? Well, remember how we did that. This point right here is 1.57. Pi root 2 is about 1.57. And this number is between 0 and 1.57, so that's how I know it's here in the first quadrant. Okay, so that's my first answer there. To get my second answer, I'm talking about sine. I want another angle whose sine is the same. The sine is the second coordinate. So I want another angle that has the same y coordinate. The y coordinate is the height. So I want another point on the circle that is at the same height, and that would be this one right there. And what is that angle? That other angle is, well, it's almost pi. Pi minus this piece. And by symmetry, this piece is the same as that one. So pi minus that. Okay, it's almost pi, almost half a revolution, almost 180. But you have this piece is missing. You have to take it away. But that piece is the same as that, and this one is that angle. So pi minus that angle. Okay, what is this though? Let's put this in the calculator. Pi minus 0.411516.846. 2.730. 00. 75808. Now that we're done, now we can round. So what are the answers? After rounding, the first one rounds off to 4.1115, and the second one, it rounds off to 2.731. Okay, so that's how you do these problems, at least with sines and cosines. Find just the first one right away by hitting it with the inverse trig function, and then draw a picture to get the other one. Be careful though, if it's cosine, you want the same first coordinate, the same x coordinate. So your line should be vertical. If you're talking about sine, then that's the same as a y coordinate. Y coordinate, that means horizontal, so draw your line horizontal to find the second point. Now, one last example is with tangent. Tangent is a little bit different, but is just as easy, if not easier, actually. So let's do this one. First, solve for tangent, divide by 3 in this particular case. So that would be tangent of x equals 4/3. So hitting it with tangent inverse, you get that x is going to be tangent inverse of 4/3. So putting this in the calculator, what do you get? Tangent inverse of 4/3. Don't round until you're done. 927295218. All right. So that's the first answer. before rounding. The second solution is going to be, well, you see, tangent is neither the x coordinate nor the y coordinate. It's neither when you draw the angle on the unit circle, and this one is again between 0 and 1.57. So first quadrant. This one, the tangent is neither the first coordinate nor the second coordinate. The tangent is the quotient, tangent is sine over cosine, so it's actually the division. So the other angle that is the same as that one is just going to be on the opposite side. So basically, when you're dealing with tangent, the answer is always going to be add 180 to land on the opposite side. So that's the other angle that has the same tangent. So in other words, take that and add pi to it. With tangent, that's how it always works. So we don't really even have to think about this one. Just add pi. So this is going to be 4.068887872. Okay, now I'm done. Now we can round. So the final answer would be, after rounding to 4 decimal places, 0.9273. That one rounds to 3. And the other one is 4.0689.